Okay, great. We are on. My name is Itai. Joining me here today is also Moran. And I think that every Zoom meeting is supposed to start with words. Can you guys hear me? And I guess the answer is yes, because we tested it before, but it's something that I think that Zoom will not work otherwise. And today we're going to talk about a guide of putting together a continuous ML stack. We'll be focusing mostly on the continuous training. We'll get to it in a bit. First of all, I want to thank you all for joining, and feel free to ask questions in the chat. And hopefully, until we finish it, no more questions will be left unanswered. But in case there will be, we'll take some time in the end for more technical questions. So you got an email with all the relevant information that you're gonna need. In case you don't stress, all good. I'll send a link to the notebook in a few minutes. But before we get to that, let's have a deeper conversation and some overview about what are we gonna present today and the workshop that we're actually gonna do. So a bit about us, Superwise, in case you didn't see. We're developing an observability platform for high-scale machine learning algorithms. Our focus is on the scaling part. So the way we see the future, or the way that the ML ecosystem is working towards, is an intense scale. So if up until now, mid-sized company were able to get along with 20 or 25 or even 50 models in production, the way we see it and the way the entire economy goes is that more and more models will be automatically created if it's to a specific marketplace or a country or a new pattern and sub-segments and many different ways that we can improve and get our data, our machine learning algorithms to be more robust and drive more value eventually. And this is where we're getting into the picture, help monitor and observe this entire scale of many different machine learning in algorithms in production. A bit about me, my name is Itai Ben Chaim. I'm an ML engineer in Superwise, doing also many other things alongside workshops and backend work and whatever comes in the way. We're a growing startup. I'm also a father, and up until 20 minutes ago, that's what's nice about the post-COVID workshops, is that up until 20 minutes ago, I was showering my 1.5-year-old daughter, and that's something that I don't know, I find very intriguing and fun. And also a husband, and I don't know, my passion and my guess my go-to would be end-to-end solutions for ML problems. And I heard a nice saying a few days ago that says, if you're struggling with deploying one model to production, then you're an ML engineer. But if you're struggling to deploy 1,000, then you're an MLOps. And I don't know, I felt like this was actually talking to me. So feel free afterwards if you want to chat and talk about stuff regarding the rest of the MLOps ecosystem. I would be more than happy to have this conversation with you. So let's go and dive straight in. So before we're getting to the entire workshop and whatever, let's talk about some challenges that we're probably coping with every single day. I guess most of the audience in here are either data scientists or machine learning engineer or data engineering on the way to become ML engineers, or even just software people who had a few tries with ML and understood the differences or the change in the paradigm of monitoring these systems, right? Because if you will go to one of those common DevOps in these days, and you'll ask them, hey, how do you monitor your software, your microservices in production? How do you know if it's working as it's supposed to be? Then he'll tell you, hey, I got few alerts and I'm checking the functionality and I'm making sure that the exit code is different. If the exit code is different than 0, then I know that something went wrong. It's quite deterministic, actually. You can know from advance what's the threshold that you don't want to pass and you want to act upon. Exactly the same. If, I don't know, the CPU is above 80% or the memory went into swap, then you know that something went wrong and you need to act upon it, right? Increase the pods, roll out or do some changes in the code, and so on and so on. When you get to ML-based products, ML-based software, then you're not testing functionality anymore. It's a bit of a black box, right? Because you want to know if the quality of the model is good, and by definition, that's not deterministic, it's stochastic, because the profile, the ongoing data profile is constantly changing, which means that just monitoring if the exit code is different than 0 doesn't mean that something is good or not. If we're going to get a distribution shift between production and training of KL distance of 2.34, is that good? Is that wrong? Do I need to act upon it? Is everything okay? And that makes things a bit more complicated. Okay, so this is what also brings us the ML engineering into this new era of mixing both software and DevOps-ish work. If we'll compare the two, Google went a few years ago and published a paper about the differences and the levels of maturity in organizations that are using ML-based products. And they came up with 5 differences between a very software-oriented team or challenges into versus the ML engineering challenges. And the first one would be the team skills, right? Each one of us probably have or worked with or is by himself a data scientist. And the actual day-to-day work of a data scientist is mostly experimental oriented. He's doing many experiments. He's exploring his data. He's trying to understand changes between different models and hyperparameters and the way it's going to work, and writing the model. But he's not very focused on writing a production-ready microservice that will be robust enough for scale and will be able to log the correct logs whenever needed and will work efficiently, and so on and so on. The development is also different, because when you're developing a software, then you're focusing on doing it optimally, efficiently, and you're just running with the actual goals of your functions, of your development. While developing ML-based will need to have the ability to reproduce many experiments that occurred along the way, and being able to decide which one worked better and which one worked less, and therefore have a different way of developing pipelines. Testing changes as well, because we're not longer testing only the functionality and the integration, but new concept of testing were introduced. So one of them would be data validation. You want to know and make sure that the data is okay and there's no changes in the structure of it, and it can be processed the way we expected it to be. And we're also testing values of the model behavior and performance. So there's new testing that came along the way. Deployment changes as well, because from now on, we're not just deploying a standalone software or just a pickled or serialized object into production or into some web service. We need to deploy a full pipeline from end to end that will be robust enough to take the data, transform it the way we want, prepare it for the training, and do the rest of the work. This one we'll see later on how it can actually be done. That maybe this is maybe one of the key notes to take from here. And the last thing is production. So production is also something that changes, because the level, like model ML-based software, its performance will decay in many different ways than a traditional software. And I mean, because of the ongoing or the changing data profiles, then the model will become more and more irrelevant. And according to that, its performance will degrade. So these are the challenges maybe that I guess you and I came across. And right now we're going to talk about MLOps. We're going to talk about two different maturity levels. So this is also part of Google's paper. I highly suggest reading it. It's not too long, and there's many things to take from it. And the first one, the level 0, they called it. It's basically me 5 years ago. Okay, I was given a task in the company I was working for to develop a model that will predict the way that units in a chip design environment, components, we can call it components within a chip, will converge according to the tape out or according to the development process of the electric gates. And we took many different features, and the work was very slow and manually, and I had to write many SQLs and many small scrapers to get the data from different sources. It was not managed on a version control system. I was not tracking my experiments. I was getting good results, but I had a hard time deploying and getting the same results in production. Things was always breaking. There was, of course, no CI/CD process to it. And that's basically a place that lots of manual work was needed in order to make it work. So as soon as I had a pickled object, I would call one of the people who were responsible for the services, and I would tell them, hey, I have a pickled object for you, and if you can put it within one of your microservices and give me the endpoint, so I'll be able to use it in other flows that I was using. And the entire thing was tiring, right? And then the next level, this is what we're gonna present and do today, is all about the pipelining maybe, and what pretty much makes us capable of continuousing the work or continuousing the training or whatever process we will see. So in the diagram here, you can see that there are two scopes or two sections. The one above is the data scientist work, which is getting the data from a feature store, validating it, preparing it for the model, running the model over and over again, evaluating each one of them, saving it to some repository or registry, and then serving it to some pipeline, which this pipeline will run pretty much the same with some minor tweaks, but eventually there's going to be some symmetry between the experimentation and the operational pipelines, and eventually you'll deploy it to an endpoint automatically, have some monitoring system in place, and have triggers or some kind of heuristic that will initiate actions upon changes in the data, right? A lot of times I'm talking to our clients and customers, and I'm asking them, hey, what's your retraining strategy? And a lot of people, a lot of data scientists are telling me, hey, for this model, we're doing retraining every 30 days or 90. And like the way I see it, we need to be the most data-driven people in the industry. And when it comes down to our day-to-day work, we're maybe easing the mind or putting less emphasis on the very important things. And this is maybe the main paradigm that we want to present today, right? We want to show that with monitoring and a very simple pipeline strategy, you can pretty much make your entire infrastructure way more robust in production. And how are we going to achieve that? Okay, that's the scope. So we're going to write the pipeline, the one here in the middle. We're going to use Kubeflow, Kubeflow on top of Vertex. We chose Google Vertex just because it may be the easiest way to show a paradigm with. Of course, SageMaker and some other big vendors are also an option, but we chose it just for simplicity's sake. During your work and whenever you want to try and put this paradigm into work and implement it, you can choose many open source tools, Argo, Airflow, Jenkins, and so on. We're going to use a registry to save our train model that is going to be containerized within a Docker image. And then if we reach some level of the validation was good enough and the model behaves as we expected it to behave, then we're going to serve it to an endpoint using Google Vertex endpoints. Of course, here Seldon and TensorFlow serving and many other technologies are available. We're going to connect all of it into Superwise's platform and initiate the webhook, the most simple way to do it, that will trigger the pipeline again. in order to fix some change. No one need to work or do a manual work after we're deploying this entire infrastructure, I'll call it. Okay, so if we'll go back a few slides back, so we're going to focus on the main blue component here and what's around it. Okay, we're not talking about data science work right now. We're going to focus on the ML engineering, and it's maybe also very important to say we did some oversimplifications of very interesting data science concepts such as cross-fault validation, cross-validation, and some other stuff. So please, if you see, I don't know, some few things in the pipelines that you say, hey, it's not the way to do it, we know, I hope we know, but we did it only for efficiency or maybe the simplicity of things, okay? So workshop timeline, I think we can skip this one, and let's dive into the notebook, okay? Now, I've shared it in the chat. You also got it in the email. I guess I'll send it again right now, just so you guys can log into it. This is also the updated one, so make sure it's got the project ID already set for you. We created the GCP project in advance, and you guys you have permissions to use all the APIs that needed for this tutorial. And this project will probably stay live for a day or two for recording and people that would like to do it offline. So maybe one more thing that I feel obliged to say. I think the Jupyter Notebook is a very powerful tool to have in your toolbox as a data scientist. Very good for storytelling. I'm not a big fan of it, usually, especially not in ML and data engineering. So we're gonna look at the pipeline in a notebook, but please bear in mind that these things, this entire script, supposed to be in different areas of your system, and it's also maybe some practice for your thought. Imagine during the work, and you can also ask it in the chat, where these components can fit right to the flows that you guys are using every single day. Okay, and that's it. So please download the notebook because you don't have permissions to edit this one. So after you downloading it, just open it in Google Colab. It's fairly simple just to connect to Google Colab and upload it. If you guys want to do it with the Jupyter Notebook locally or Visual Studio or whatever you feel convenient with, just make sure that you have GSUtils and G-Cloud installed, because we are using it every now and then just for the automation of creating buckets and ensuring some. I recommend do it in Colab because the integration with GCP is way simpler here. So let's start. We're gonna start by setting up the environment, and then we're gonna do a very simple pipeline. The first pipeline that we're gonna deploy would be just from extract data stage all the way to model validation. It's gonna be a 5 or 6 steps within that. And this is primarily the side that the data scientists will be responsible for, because they know what data they need to extract. They know how to do the validation, creating the scikit-learn or the pipelines and the transformation that they need. After these steps, we will have 2 more steps that are more engineering related and ML engineering related, which is registering this model, this pipeline into Superwise for monitoring, and then deploying it to an endpoint with a short break for some cool Flask development that we're going to do here live. Not very complex. There's not going to be many super sophisticated Python stuff in here. Try to keep it as simple as possible. So setting up the environment, pretty simple. We're gonna run this one. What Google Colab does in the background is allocating a VM for your use. And in case you're not going to run it in 20 or 25 minutes, I think it's being released. The memory is being released. So you need to run and start all over, sorry. Okay. And right now we're going to start by typing in our username. I want to see many people running it, okay? Because we will see who is running it and who is not, because we're going to create many pipelines. And don't worry about it. We got many credits from GCP. So let's stress test them and feel free to run it in parallel with me. So enter your username in lowercase because the endpoint will not allow you to use capital letters. Afterwards, the bucket name that we're going to create and work with, the region that we're going to work with GCP, project ID and project number. In case you guys are using your own company or your own project, just put the project ID and project number here. So I'm going to run this one. And then there's going to be an authentication coming up. It's going to ask you to sign in with your user, just to make sure that you have the relevant permissions. We used Terraform in advance to just grant all the people who signed in the relevant permission. But in case you're feeling, or you're not feeling, in case you're struggling and something is not working properly, feel free to look at it, look at the recording and contact us afterwards, and I'll be able to guide you through the process of the definition. So the next stage we're going to do is just config set the project I did to set in before, and we're going to run and create a new bucket. Okay, so GSUtil is the Google storage util, MB is shortcut for make bucket, in a region we defined, and the bucket name. I guess according to your username, you will have different bucket names. Okay, so I do want to see many different buckets being created. Okay, and now we're going to make sure that we have the correct permissions to ls to list it, and we're going to do some installations. Now this installation might take a while. Meanwhile, let me show you like a good cooking show from the 90s. I prepared in advance a few pipelines that I already ran a few hours ago, and I just want to show you how a pipeline looks like, right? So I went into GCP, looked for Vertex, this nice dashboard came up, and this is the actual pipeline that we're going to run. We're going to have a step for loading the data. Soon enough, you're going to see what data we're going to use. It's going to output a dataset, which is going to be the input of validate data. Afterwards, this validated data frame, which will make sure that there's no nulls and some other validations, will be sent to prepare data step. This is going to split it into 4. I guess you already know what function I'm going to use. Xtrain and Ytrain, Xtest and Ytest, while the Xtrain and Ytrain are going to go to a train model component, which will output the serialized model or the serialized pipeline, a scikit-learn pipeline, which going to go and fed into evaluate model, validate it, and then we're going to have, these are the steps of the data science part, and afterwards we're going to have 2 more steps. I'll get to that in a bit. Now, I hope the installation is finished. That's perfect. Let's get rid of the output because it's, now we have to restart the kernel in order to have all the libraries within reach. And something here that's optional, so you don't need to run it, you don't have permission to, but again, if you're using your own project, your own organization project in GCP, just run this because we need to enable few APIs in order to make this pipeline or notebook run. Now, we're going to need to redefine everything because we restarted the kernel, so I just copied it from the second cell, and I'm going to run it again. And right now we're going to start. That's it. GCP is ready. We can go ahead and work with it. The first 4 lines are quite obvious, and then there's 4 lines that I would like to quickly go over. So we're going to use the storage SDK and the AI platform. AI platform is what helps us use SDK commands to initiate work with Google Vertex. There's also Kubeflow, which we use few objects from. One of them is the compiler. It's going to take our pipeline, the code, the Python code that defines the pipeline. It's going to generate the JSON out of it. We're also going to use DSL, so it's a domain-specific language. I think that's the acronym. It's going to help us define some conditions. Component, pipeline, and the rest, you'll see it while we go through. So here I'm going to run the imports, and then I'm going to create my endpoint. Feel free, if you guys want to create your own endpoint, just change the name, make whatever endpoint you feel like. And then we're gonna start with building the pipeline, right? So we're gonna start with the first two steps: loading the data and validating the data. Super simple steps. We oversimplified everything, so we're not using a fancy feature store and some other very big blown components. So we're going to read the diamonds dataset that I guess many of you are familiar with, one of my tops anyway. And then we're going to filter the diamonds and create a dataset of only the smaller than 10,000 priced diamonds. What this is supposed to create is that our trained model will be familiar only with these kind of diamonds. This will help us eventually simulate real-time data with the expensive diamonds and see how the model starts, some shift is occurring in the data, and then a trigger is occurring and something happens, right? We're going to initiate a new pipeline without anyone doing any work. So something that you probably saw is the component decorator, the component coming from Kubeflow. This is basically saying to Python that I'm going to define right now a Dockerized or a containerized step, which is this low data blue cube step. And you can pretty much define what packages are needed. You can also define what base image you want to use. So if it's Python 3.7 or 3.9 or Alpine and some other Python images. And you can also define a JSON component, like a JSON file that will be generated from this component. So you can share it between different pipelines. In this case, I'm not using it. I'm creating one pipeline for one JSON for the entire pipeline, but you can definitely create many different small ones and share them in different processes that you probably have. So this is the first one. I'm going to run it, just the definition. The next step, not really needed to be run it, just to show you the features and the data that we have here. So we have 10 features, which is the carat of the diamond, the cut, the color. If anyone is going to propose soon, you guys can take this pipeline and try to see if you got a good price for the diamond. And you have the price. And this is pretty much how the dataset looks and some information about it, not really necessary. The next step, the next component, I would say, is the validate data. Now we're going to make sure that the data that we got from the extract one is good enough for training or for preparing for training. Two arguments that I skipped before, which I think is necessary to mention, are the input type hint with a dataset type and the output. What these actually mean, behind the scene, what Kubeflow is actually doing, it is pretending to work with your local storage. However, GCP is implementing something called min.io. I highly suggest you go and read about it. It's cool technology, which pretty much abstracting away all the work with cloud storage, whether if it's S3 or GCS or any other. And you feel like you are working with your local storage, but what actually happens is that you're writing to GCS, which is very useful because you can share the so-called local files with different processes or different flows within your system. So that's also something worth mentioning. And the way dataset object or hint is working here is that during runtime, few attributes will be allocated to this dataset. One of them would be a path attribute. So we don't know what is the actual path or the URI for this specific data frame. But as long as we're getting it on runtime, then we can read and write from it without actually caring. It's like a temporary file. You can refer to it as a temp file. So that's something very useful. Of course, beside dataset, there are many other artifacts that you can use, I suggest you go and read in Kubeflow if you're interested. Now this step pretty much is gonna make sure that all the numeric features are numeric. It's gonna generate a new column called record ID, so we will know how to connect the label to the prediction, and it's going to fill the NA with the average of the column. Very simple. The output is the validated DF from here, and as you can see, I'm just writing it to disk without the index, of course, because we have a column for it, and we're just using the path that was generated, right? So if I'll go back to the pipeline, just to make sure that it's clear enough. So this one is the dataset object of flow data. So maybe the validated DF. This is the output that we just saw. And here's the URI. It has been generated during runtime. I can download it, and I can use other tools to download it and use it somewhere else. But it was defined on runtime. Great. So we finished with the validation step. We're going to move to prepare dataset. And as I said before, we're going to split the validated DF into 4: X-train, Y-train, X-test, and Y-test. I'm going to use the very common train test split method, and going to write all of these. Okay, so one step, new package was installed here, and something maybe, okay, we'll reach to it later about the way that this thing is running. Okay, the next component will be train the model. It's going to get the X-train and the Y-train, and the model artifact will be the output of it. We're defining here a pipeline. Now, it's not a training serving pipeline like we're writing the Kubeflow one, but this is an scikit-learn pipeline that's gonna have some category encoding function and a simple imputer for the numeric columns. This thing is what I talked about before in the differences between software and DevOps and MLOps, that the deployment changes because we're not just deploying the random forest regressor. We also need to make sure that from each side, like before and maybe even after, there are a few steps that the data will always flow through. Okay, so this is a very useful technique. Now, as I said, the data science work is abstracted away here and oversimplified. We just chose the best or close to the best parameters, the hyperparameters for this specific model. We're going to use random forest regressor. It brings the best results on this specific data set. And the idea here is that we're going to use a very strong and robust model, but the data is not the actual, like it's not the entire data set. And this is what makes us, or makes the entire scenario as close to the real world as possible, right? Because we did everything we could from ML engineering and data science work. However, something happened in the real world and causes us some shift and errors, I'll say, or some distribution shifts. Okay, then we're going to create the pipeline, run a cross validation, and min the score. We're going to use only twofold. Of course, it's not very useful. And after that, we're going to save. So one thing maybe here, we're going to use joblib to serialize this object to the path. But in addition, this model artifact, which is different than dataset, this is a model. It will also have another attribute called metadata. This is like a dictionary that you can add data to it, okay, and then use it later on. Now we're going to move on to the evaluation of the model. We're going to run this one. So we get the model artifact from before. We get the X-test and the Y-test from the validation of the dataset. We're going to output the model performance, and we're also going to generate a small HTML file with some scatter plot just for later use, right? We're talking about reproducibility, which is it's not coming in this pipeline in many forms, but specifically, we're going to show just a simple technique to use artifacts that are not very technical for the engineering part, which is just nice to have and visualize performance and other stuff. So we're going to use Seaborn library for it. So this is why I installed it in here. reading the data and loading the serialized object. Look how simple it is to pass from one component to the other. We're going to calculate the root mean square error and the R2 of our model on the test set. And eventually we're going to write or encode the seaborn into an HTML and write it, okay? Kubeflow on Vertex give us a very nice capability of actually visualizing within that dashboard that we saw. We're going to see it in a few seconds. The next step, and there's a reason I'm running as fast as possible on these steps, because we care about the monitoring part and the pipeline. So sorry if some stuff are unclear in here. Make sure that if something is unclear, ask you in the chat, and I'll try to reply or do it afterwards. So next step, validating the model. We're going to make sure that few conditions are okay. We're going to read all the data. We're going to use, instead of a validation data set, I just chose to do it on the entire data set from before, and make sure that the R2, or sorry, the RMSE of the new, of the current step model will be better or smaller, better in RMSE, will be better than the model that we had in the test stage, okay? The performance that we had in the test stage. And the reason is just to make sure that our model improves when it gets more data, okay? So we're going to print some logs out. We're going to write the new model metadata train score, and we're going to log some metrics to model metrics, which is of metrics type. And eventually we're going to use some condition. The condition that I chose here, the most simple one I came up with. I'm just making sure, like I said, that this model here will be better than the one before. Also, that the R2 score will be greater than 0.95, and the absolute error of the cross-validation mean would be less than 1,000. Now, that's not the best scenario. You guys can come up, I guess, with way better scenarios. For example, compare this the performance of this model with the one that's in production right now, and then define maybe to run some A/B testing, or maybe compare it to other baseline that you came up with. Now, Vertex is not working with Booleans like Kubeflow. Therefore, I used a tuple. This is why we're returning here a name tuple with output and a deploy param, which gets the string that I just chose here. Now, this is it for the definition of the components within the pipeline. Now let's get them all together, right? So we're going to use a new decorator called pipeline. It's going to get a name, description, and the root where all the work is going to save and read files from. And exactly like we saw before, we have the ML pipeline here. The first step we defined would be load the data, didn't get any arguments. And after this step is done, then raw data here will get all the outputs that was generated in the one before. So we can pass to validate data, the dataset output from this step, and so on and so on. And this is basically a code that defines the diagram that we saw before, okay? The train model, the training model will get the X train and the Y train, while evaluating the model, we get the X test and Y test, and the model artifact that came from the train model task. Okay, so maybe these names are not, I'm just thinking about it right now. It should have been raw task, validated task, prepared task, and so on, like I did in this one. Okay, we're gonna run it. Nothing happens yet. And then we're going to execute it. We're going to use AI platform pipeline job to execute it. Just before that, we're going to use compiler compile in order to take this entire Python script that we just wrote and make a JSON out of it. And then we're going to run it. Perfect. Seems like it's running. And then just here, I put here the ls-lthr, which you can see that just now we got an ML pipeline file with a JSON, which shows us everything that we just executed. This is also very helpful for caching. So if we're going to change one of the first steps, then all the other steps, according to this JSON, will be ran again. In comparison to one of the late ones, and then the first steps would be cached. So I'm going to go to Vertex right now. I'm going to choose pipelines, and I'm going to look. The basic pipeline of Itai is running. Now, I wish I would have seen here more names. So feel free to run maybe today, maybe tomorrow, and use this pipeline. This pipeline will be the most basic one. And you can see what's basically happening right now is GCP is looking for compute or VM that it can allocate this step to. This is why it takes 54 seconds in comparison to running it locally, which will be just in a second or two. And this is why this the pipeline might take a while. Okay, the basic one will take 10 minutes, but again, we have cache in place, so it's going to run only once. Hopefully, if no bugs will occur. Great. Now we're going to move on to the next step. So until now, what do we have? Going back here. So we have, let me see if I can get it a bit bigger. No, it doesn't really work. Okay, so what we have here, we have the data extraction, data validation, preparation, training the model, evaluating it, and validating it. Now we're going to move on to the registering our model to Superwise. We're going to use Kubeflow pipelines as well to do so. And it will happen only if validated model will give us true. Okay, if the last step that we defined with the condition will give us true. In case it's good enough, we're going to sign it up to Superwise, and we're going to start monitoring it. So in order to register your model to Superwise, we're going to need to generate a token. I hope many of you signed in to the platform in advance. If not, just watch me and see what I'm doing. Understand how simple it is to use. First and foremost, I'm going to use my account. I'm going to log in. And this is like the clearest. Each one, it's a freemium version. So each one that signs up gets 3 models to monitor for free. And there's also here the demo one, which is fraud detection. Also very nice to look and see how we can utilize the monitoring and the observability capabilities. And now we're going to generate the tokens, right? So I just click down here and I chose personal tokens, and I'm going to generate one, right? And I'm going to call it workshop pipeline. And I'm going to create it. And here's the secret and the client. Of course, in real time, you're going to save it in a vault or as a secret. Right now, just for simplicity, we're going to use it in front of you all. And I'm trusting you not to do anything vicious, although you cannot really. And great. So I'm running this one, define the client ID and the secret. And then I can move to the next step and run register model to Superwise. Now, again, this is just a component. So it's not going to run right now. And before, let's talk about this one, and then we're going to execute it. So what this component is going to get is going to get Superwise and Pandas. Superwise is already in PyPI index. So you can just pip install it. And this is our SDK. As I said before in the beginning, I hope you heard me, is that we focus on scale. Therefore, the UI that I'm presenting here is not our first goal when we're developing our platform, right? So it's a platform, you can pretty much do anything from the UI, but we're API first. When we reach a point when we want to develop a new feature, first we're going to write it as an API, then we're going to write it as an SDK function or as an SDK capability. And in parallel to it, we're going to do the UI and whatsoever. So something to bear in mind, everything that I'm doing here from the UI will be available to you in automation using Python or any other language when you're using API and REST API, okay? Something to bear in mind. So registering the model to Superwise would be getting the model name just in order to follow. This is the model name that we're going to use, the client ID and the secret. Not a good practice to pass them on in Vertex, but you can use Google secrets and same and read it from within the step. We're going to give it a baseline. Baseline is actually data that Superwise will learn and understand many different things about your data in order to give you better monitoring. And we're also going to provide a timestamp just to get the versions. If we're going to create many versions to a specific model, then it's going to be unique. So when I'm saying model, maybe I need to fix the terminology in here. In Superwise's terminology, a model is just a problem that we want to solve. A version of a model, for example, predicting the price of a diamond. Okay, so it's a regression problem, and we're going to predict the diamond prices. Now, the version would be the point in time where we did our training, we reached some level of certainty, and we decided to deploy to an endpoint. This is what a version means. Okay, it's like a tag. And register to Superwise will give us two outputs back, would be the model ID, the unique model ID, and the unique version ID. This will help us send the data to the correct monitored version of a model. Now, we're going to use the Superwise's SDK. We're going to use client ID and secret for authentication. And then we're going to make sure using our SDK, we're going to get the name of the model and make sure that it's either the first one or there's also already a model of that name. If it's the first time we're creating this model name, we're going to create it using the create function, get its ID, and make sure that this is the first version. Otherwise, we'll just get the model ID of models coming back from this one. Now, the baseline data is given to us from an earlier step. And I think from the validated data set, we're going to see it in the diagram in a few seconds, the validated data, yeah. And we're going to read it, and we're going to assign a new column to it, which will be the timestamp. And when I'm showing here a timestamp, usually if it's time series data, then this step is already there. But sometimes we want to create a new step which tells us when this record, this data point reaches our prediction service, okay? And this helps us understand ranges of times and seasonality and so on. So that's something important to have. Afterwards, we're going to do inference on the data types of your baseline data. We're using different category, like more general categories than NumPy, for example, or pandas. So we're going to infer what are the correct Superwise data types. We're going to run a summarize function, which is highly important, by the way, because what it's actually doing in the background, it's async function. It's not going to block anything, but we're calculating many core statistics measurements on your data. One of the examples would be the feature importance and so on. And this also helps us monitor the model better. If this is not the first version, then we're just going to get all the version of this specific model and then create a new one. And eventually we're going to create a new version and activate it. So when the version is activated, it is good enough to receive new data and also being monitored by policies. We'll see what policies are in a second. The pipeline will be exactly the same pipeline as it was before, with a new DSL, domain-specific language condition, which is the validated model output deploy, if you remember from before. And if in case it is true, then we can move on to the next step, right? So I'm going to run this pipeline. I'm going to look and see what's the status here. So we reached our evaluate model, and I think it is safe enough to run it. And I'll execute it. Perfect. So now we can see that a new step came up, Superwise pipeline. And you see that all the steps that already that were cached and finished successfully are not going to run again. And right now it's in the evaluation model. Now, I think that's a good point to go and explore the diagram itself, the Kubeflow diagram. Let's see. Okay. So I'm going to expand the artifacts in here, and we talked about the dataset types, but right now I want to show you some other ones. It still did not generate in here, so I'm just going to look in a different pipeline. And if you remember, we said that we're logging metrics we're also generating an HTML visualization, and we're also saving some other information about our model. So the first one, we're going to look at the model artifact, and we're going to see that the train score, it has a property that we defined, if you remember, and it's the train score, the cross-validation, the twofold cross-validation mean is 447, which is great. Just to remind you, the prices ranges between 0 to 1,000. So we're good with it. The HTML report that evaluate model gets a button of view HTML, and we can see seaborn, scatterplot, like the most simple one, probably in PyPlot, a predicted vs actual prices of the diamonds. So that's some other visualizations that we can create. And here are the model performance. This is our R2 metric and the RMSE. So we see that it is above 0.95 and the RMSE is 431, which is bigger, absolute value a bit larger than smaller, I think, than the one we saw in the cross-validation. Model metrics, again, the same thing, and a baseline. Now let's go back to the running step. Let's see where it is. Okay, great. So it is validating. By the way, as I said, steps are taking a bit longer than it was usual on your local machine. So don't be scared if you don't think that something went wrong. That's what I'm trying to say. Great. Now, while this thing is running, it's probably going to take 5 or 6 minutes more. We can move on to the next step. And the next step would be outside of the scope of the notebook. We'll get back to the notebook afterwards. And what are we going to do right now? You guys are welcome to do it on your own. We're going to clone this model orchestration repository. We prepared small Flask application. What happens with Google Vertex is it gives you 2 options, basically, for an endpoint. One of them is use their own out-of-the-box images, which are awesome. They have all the capabilities that suits most of the scenarios. However, we are trying to introduce a new scenario where from within the service of the prediction, we also want to log the ongoing data into the monitoring platform, okay, in order to make sure the Superwise is monitoring and sees all the predictions. So the solution that we came up here is to write a custom image. This is the second option that Google Vertex allows you, and write your own prediction service and just deploy it to their Artifactory and use it. So later on, we're going to write a new component, and this component will be the actual deployment. Right now, we will git clone this one into locally and have a look at the service and write it. Okay, so I'm just in one of my location on disk. I'm going to git clone this one. Oh, great. The model orchestration. Let's look at it and let's open PyCharm here. Right. So we're going to do something like this. New project. New project. My go-to is Vim, but I think it's like exactly the opposite of a notebook. So opening code on Vim would probably be more overwhelming than useful. I'm going to do this one, Superwise model orchestration, and we're going to open this one. And let's trust it and open. Perfect. Save this one in a smaller window. Great. Now, the most simple Flask application you probably came across, okay? And we don't need to look at the README as well. We have a Docker file. We have a requirements file. We don't need this one right now. This is the requirements. We're going to need Unicorn, Flask, and Superwise application. The Docker file, these ones, from this one all the way to this first argument, these are not necessary. They are necessary for the deployment to an endpoint, but they're very useful when we're trying to test it locally. And I encourage you to do testing locally before you're deploying to Vertex, because as you saw, it takes quite a lot of time to deploy to an endpoint. If it takes about 1.5 minutes to allocate a machine for load data, then it takes way longer, about 10 minutes last time I checked. I think 9 minutes and 17 seconds was the last time that my service got VM allocated to. The reason is it's a static station because they want to keep the IP and all the other network parameters static, and therefore it takes a bit longer. I didn't read much into ways to optimize it, but I'm quite sure that if you have already compute in place, you can probably go and utilize it and save the time. Now, inside this one, we're going to see two directories. The first one is the credentials, very simple credentials that, not simple, just for the service account. So when you're creating a project, you're going to open a service account and not use your own. So we're going to give this image all the permissions needed to run and work in front of GCP. And we're going to have our predictor. So the predictor server will have two endpoints. The first one will be predict, as simple as that. The second thing is health check, exactly like Kubernetes. Google, before it deploys your Flask application or your Docker image, it makes sure that it's healthy and able to get responses, requests. And the second one is the predict. Okay, so diamond price predictor will be used in here. Okay, again, not the best practices. It's mostly for understanding the paradigm and the concept. And the predictor is going to do multiple things. First of all, it's going to implement a predict function. So this is the one that we're exposing to the service. And from within that, besides just using the model that was generated in Kubeflow and loading it here, each time that a prediction will occur, we're going to use this send monitor data, which I already implemented, in order to send the data to Superwise. Okay. Now we can argue about doing it asynchronously or in a multi-process or using a celery worker or many other different ways, or even sending a Kafka message. You can do many different things. Again, for simplicity's sake, I did like the list, and I'm going to write it like in the most simple way possible. So set model will download the job lib or the serialized object from GCP, from GCS. It's going to load it to a property, and then it's going to use a software, a Superwise driver in order to log that data. Okay, so first let's go and implement the predict. This is how the instances are arriving to the prediction requests are arriving to it. And just to remind you guys, we have a predictor in place, so we need to use the predict. So the most simple way to do it is just to have, I don't know, predictions, and then do predictor, predict, right? And give it like the request JSON instances, okay? Because as you can see, you get a request that looks like this one. So you have instances, and that is an array of many different vectors. And after we have our predictions, we can just go ahead and return a JSON file. I already, as a hint, I already imported it. So JSON file, JSON, come on. Why did not? Thank you. And we're gonna do predictions, would be the predictions that we got with, I don't know, prediction prices. Great. And we're also gonna do transaction ID. This is something that we use in Superwise. It's not mandatory, but we use it just in order to, let me see if I can enlarge the text, because Command plus is not working for me right now. I just want to make sure that everyone can see. So editor, thank you. General, sorry, it's the font. Okay, let's have it in size 18. Whoa, looks awful. But I'll take this one. Okay, so predictions, and then we're going to return also a transaction ID. And I think that's pretty much it. So what we want to do is, as soon as new request comes, probably most of you already implemented such microservices. As soon as you get few requests, process them, predict whatever needed, do whatever else is needed, and return it. Now for the health check is even simpler. We're going to do resp equals JSON-fi and health equals this format diamond prediction is healthy. Great. And resp status code going to be 200. Return it. Superb. So this is it for the endpoints. As simple as that. 7 lines of code. No, even less. Okay. And now we're going to move to our predictor service. Okay. This one a bit more complex. Let me just move all these. Okay. And so we are going to implement the set model, because if you saw before in the service, we're going to use the constructor and set the model in here. So this is where we work with GCS, or all the Google storage application. You can go to Google and look. It's pretty simple if you guys are working together with me. But so we're going to do storage client, and we're going to call it the storage SDK. So we have a storage client, and now it needs a bucket. And the bucket would be environ, as you remember from the Docker file. So we provided here the bucket name, and it's an environment variable. Okay, so we can go back here, say just get me this one, and well, we have a bucket, and we have the storage client. We can go ahead and do bucket equals storage client dot get bucket. Perfect, and the bucket name is this bucket name. I think we can do it like that. And let's create a blob. Blob is just a reference to an object that we're going to write, that we're going to read or write. Bucket blob, I think. Yes, it is. And let me. Okay, yeah, perfect. So we want to get this one. And the reason this is specified in here, because we got it from environment variable, which is the model path. Soon enough, you're going to see how the pipeline, the Kubeflow pipeline, the last step, will generate this one for us. So we have here the model path. And then after we have a blob, we can read it with many different ways. I chose to do it with a temporary file as temp file. Perfect. And we're going to do blob download. Let's have, the completion, download, but this is not a file, download to file. I want to say that I'm not very happy with the Copilot, but sorry that so temp file, thank you. And then temp file 6.0, because we want to go to the beginning. And there we can load, use joblib to load temp file. Perfect. And when this context finishes, we have, let's print something, maybe something goes wrong. We loaded the model. Perfect. And let's return it. Great. So when this function will run, it's going to create the blob, going to read into a temporary file and load the model that we're going to use. The last thing that we have to implement is the predict. The predict is fairly simple, as you see the docstring here. So you get the instances, and we're going to return the API output as a dictionary. So we're going to create a data frame, because I feel most comfortable input df working with data frames. It's not mandatory, but again, simplicity. So we have an input df, and then we're gonna create a new. So if you remember, we are not getting a vector with prediction. We need to add a new column to it. So it's this one, and it's gonna equal self model. No, self model dot predict input data frame. Perfect. We're going to have a new column with the prediction that we wanted, and then we need to log the data into Superwise. Okay, so send monitor data, and we're going to send the input data frame, because if we're going to look up here, it's going to get the predictions, the input data frame that we just added, and I don't want to send only the prediction. Well, let's just send all the production data, so Superwise will be able to follow and generate some other nice trends and KPIs and so on. And eventually API output would be, thank you for nothing, like we did in here. So not exactly, transaction ID would be transaction ID, perfect. Here, something nice I just learned a while ago is you can do reformat from here, and it helps you format your code. Okay, and we're going to close this one, and the predictions would not be this one. It's going to be the input df predictions column Siri, if we want to, and values to list superb and a comma. Great, and while we edit, return API output. I think that's all we needed. Let me see. So we have an input data frame, and yeah, I think we're good. We're good to go. Typo in word transaction. Okay, that can be a problem. Transactions. Okay, we need Grammarly for so where is this coming? Yeah, so it's not transactions. There's going to be only one, if I remember. Yeah, it's coming from here. So you know what? Let's copy this one. Okay, transaction ID, and the transaction ID would be this one. Superb. So we have our input data frame with a prediction, and I think better call it predictions because it's be more than one, and it's also going to fit this description here. And yeah, it seems to me quite legit. We can go ahead and test it. Now, something to bear in mind, as I said before, you're going to need credentials in order to even to read the data from GCS. The way I'm doing it is just opening a terminal. I created one in advance, and I'm going to do the following. So we, first and foremost, we need the service account key file. So I already created here a resource directory with this one, and I'm going to copy it into our repository creds.json. Let's look at the, yeah, perfect. So we changed three files, the credentials, the service, and the server. And right now, let's go ahead and test it. Let's try to build it locally. Let me see if I have Docker PS, sorry. Okay, nothing is running, which is perfect. And I'm going to do Docker build. I think this one is it. Okay, great. And as you remember from the Docker file, we provided these arguments. So we need the model path, where to load it from. We need the Superwise client ID and Superwise secret in order to know, to authenticate in front of Superwise. We're going to need model ID and version ID to send the prediction to the correct monitoring version of a model in Superwise, and the bucket name because we need it for reading. The Google application credentials would be the ones in the Docker image, and I think I can go ahead and run it. It's already cached because I'm not showing you a workshop I haven't tested before. So this is it. Just, you know what, in addition, I will add a shell script. We'll get to this one in a second, but I'll add a shell script exactly like this one with a make file. Everything will be available in GitHub afterwards. This one and the pipeline, of course. So I'm going to show you later on. I'm going to upload all those commands so you can use them. So I just passed all the build arguments in here, and now I can do Docker run and map the same port to the same port. This is also the same port that GCP would expect me to listen to. And let's run this one. Okay, so I already have something mapped to it. This is why I did Docker PS, Docker RM on this one. Perfect. Let's run this. Great. Docker logs. Look in this one. Okay, so we have an error, which is storage client. It's not callable. Okay, that's nice. Okay, let's go here. So this one, what am I missing? Can open. Let's open here the storage. Aha, I know what I'm missing. .c. See if it. Yay. Okay, so just a capital letter client. So we're going to change this one. Go back. And this is the reason, you see, if I would have just deployed it to the repository, it would have taken 10 minutes to figure out this small step. So first and foremost, let's get rid of the containers we just created and build it again. Take a second. Now, I'm going to run it. Docker logs. Good. Run. Great. Seems like it is working. Let's test it a few more times. Of course, we can, I don't know, do some CURL and send. Yeah, these are from, yeah. So we'll skip this one. I already tested it. It's still alive. Docker image. Let's do kind of like this. Docker RM. Get rid of it because I don't want it running in the background here. To keep K minus F. Okay, dead. Perfect. So we have a Docker image ready to be deployed to an Artifactory. Now I went ahead before and I created using GCP. I created a repository for storage. So it's called Artifact Registry. And you can choose many types. What do you want to keep here, right? You can keep your models and packages and whatever you want. I use the Docker Hub, the Docker registry, and I created this repo. And then you see that there's already image that I deployed in advance a few days ago. And then we can go ahead, go back here and look in this script, right? So we're going to use the repository that I just showed you with the project ID and the region, and we're going to call this image diamonds predictor. That's all we're going to need. And we can go back to our shell and do source build and push. Let's run it. So it's going to build it. Of course, it's already cached as well. So just a few tweaks. 105 kilobytes will be uploaded, and afterwards it will be pushed and we will be able to use it in our flow. At this point, we have a Flask application. We have a pipeline that created a model in Superwise. We're going to look at it in a few minutes, and we can go ahead and look in the final step of the pipeline, okay, of the training serving pipeline. Now I'm going to go back to Vertex and make sure that the Superwise step finished successfully and nothing went wrong. Looks nice. Let's scroll down and we can see that the condition here was true and we have registered successfully a model to Superwise. In a few seconds, we're going to see it. Just before that, let's go and deploy our model to an endpoint. This is, I think, what we all came here for. So we're going to use the component decorator again. Feels like years passed since I introduced you to this component thing. It feels like time goes. And deploy model to an endpoint going to need a project, GCP project, a location, the region, a bucket name where it can read and write the data to, timestamp just to generate and unique IDs, Superwise client ID, Superwise secret, not the best way to pass them in here. Again, config maps and secrets is your go-to. Model ID and version ID where to send it. Serving container image URI is actually the artifact registry, the Google Artifact Registry repository and image and latest, like the last image that we uploaded. And then we're gonna input the model that we want to deploy and send. We'll see why in a few seconds. And the output would be just the information about the Vertex model. Okay, you'll see why I used it. Now I'm going to run this one just to generate it. So we're going to do, let me just run it before, because it can take a while, as I said. The pipeline is exactly the same, and I'm going to run it, and then we can go over the code. So yeah, it seems like it is running. That's perfect. Let's go back. So deploy the model to an endpoint. We're going to use the AI platform SDK. So right now we need to install it in this containerized environment as well. It's not enough that we have an import of it in the beginning. There's going to be a create endpoint function, exactly the same function that we had for Superwise. Make sure that if this endpoint has not been created before, then please create it and then serve a model to it. So there is a differentiation when in Google Vertex between models and endpoints. So you can send many models into one endpoint. We'll see why in a few minutes. We're going to filter it by name and so on. In case there's larger than one, take the most recent one. And if it is the first one, just create a new endpoint, okay, with the display name, project, and location. Upload the model to GCS is why we needed a model as an input. We needed a model that we trained and validated, and we want to upload it into a new place. We don't want to just keep it in the pipeline's temporary areas. We just want to create some artifactory of our own based on storage, just in order to reproduce or change models in the future if needed, and keep a record of all the artifacts. Something to keep in mind when talking about ensemble learning. Sometimes if you are misusing or misdefining a data type and you're taking a numeric or a continuous feature and you're defining it as a category, then the model, the actual serialized object, can grow to huge sizes, okay, depending on your data and so on. So when working with ensemble learning and random forest and gradient boost, gradient boost and so on, please be cautious when defining features. Okay, that's irrelevant comment to our talk today. Now, we're going to upload the model. We're going to create an endpoint. We're going to upload our model with a timestamp as a job lib to the model path that is going to be generated during the run. We're going to upload the model using the following parameters, and this is very important. So please stay with me. The display name, less important. The serving container image URI, it's something that we're going to provide to this step. We're going to tell it on which port it should listen. It can be an array if you're going to do multiple functions on different ports. Health route is what we defined in our endpoint. I think I ran too quick and didn't show you, but if we go back here and we're going to look at the server. So we defined diamonds v1 and we created diamonds v1 predict. So exactly the same, diamond v1 predict, and then all the environment variables. This is why in the Docker file we don't really need to specify all of them, and it was used just for the local testing. In this case, we're going to provide the model path and bucket name, client ID, and all the Superwise parameters. Eventually, we're going to run model deploy. Model deploy is going to specify the machine type. You can go ahead and experiment with different machines and images and SKUs in order to see what works best for you. Some are GPU accelerated if you're going to need heavy, if you're going to do heavy workloads that's needed, that the GPU is needed. I chose here the most simple and small instance that GCP provides, and I'm going to deploy the model to an endpoint with a traffic split. And that's something that I fell in love with that argument, I think, because this helps us gradually change our models without doing it in once. So for example, if we define, Superwise all of a sudden realized that we need to create a new segment, okay? Because some segment within our data, some subset in our data is having different attributes and distributions and so on. We can go ahead, define a new model, do a train split, and look how the new model will act and work on it. We can also define, in case we're not sure that the new model is the best one. So we can define a deployment strategy and do, it's also work with other microservices, not only in ML, but having that as an argument really ease things up for you. And we're also going to have a display name the same as the model. Eventually, we're going to do a Vertex model, which is our output, just to remind you, and it's a model. And we're going to specify the URI as the resource name of this one. We're going to need it for later on. And right now, I think we can go to Superwise while this step is running. Make sure it is running as we want. Great. As I said, it's going to take a while, and we can go back to Superwise platform and have a look what happened so far. Okay, so I'm going to close this and close that and have a look. A new model in our main page was created, not only fraud detection, and a new version to it. Interesting enough, why do I have two? Okay, that's something that I will have to look. I'm not sure why. I'm thinking about maybe the two pipelines that I ran. And okay, let's make sure. I'll make sure that number 20, this is the version ID. We do follow unique IDs in the, like we show them, we expose them, so you can use them in the SDK in here. Okay, and now let's go into this model and have a look at it. And let's see our baseline data, because we don't have production data yet. And yeah, great. So it seems like Superwise did some analysis on our data and shows us the distribution. And we see that caret is of high importance. And we see that price is a label, so it has no importance. And I think we can also see predictions in here. And because it is the prediction value, it's not, and the rest are features. So that's great, understood on its own. Trends are not necessary right now. We're going to create them later on. And right now, let's go ahead and create our first monitoring policy. Of course, we can do it from the SDK. Just for simplicity's sake, I'm going to show it from the UI. So it can also be done from here. Adding a policy, we're going to choose from the templates that we already provide. Of course, you can build your own. And we're going to do feature stability because, as I said, we're going to try and send a lot of data. And it's going to create a feature stability because we're going to do the expensive diamonds, which of course has different features too. So we're going to do a metric shift, and the threshold setting will be automatic. We'll let Superwise choose it for us. And so yeah, as simple as that. Let's use this template. We call it trigger pipeline policy. Okay, just trigger pipeline. Perfect. Okay, sorry, I forgot. So let's add a new integration. That's important. So we want something to happen when the policy or the monitoring discovers some event or some change in the feature stability. So you can define notification. I think the most useful one is the webhook, of course. And what's going to be the URI of that webhook? So I'm going to close this one just for a second. I went ahead again before, and I created the cloud function exactly like Lambda. There are cloud functions here. And this thing comes handy just to prove the point of, usually in your system, you're going to have many microservices doing many different stuff. And one of them will probably be suitable for having an endpoint to trigger a new pipeline. Okay, maybe it's your pipeline manager, maybe it's one of your prediction overview or the data extraction or wherever you find fit. And I just chose a very simple source code. This source code is going to do just this. Okay, this is the entry point, and it's going to read from GCS a JSON file, which I created in advance. The only change between this JSON file and the one that we generated is that the extract data step will not have the line that filters only the less than 10,000 USD price diamonds. Okay, so we're gonna retrain. We're gonna do a retraining on the entire data set, which will help us realize that the new data that came, which will probably make our model more robust to the new data that we're going to simulate. We'll reach the simulation part in a bit. And then exactly like we saw in the pipeline, we're going to do an init for the AI platform. We're going to create a pipeline job using this one. We're going to call it incident triggered ML pipeline, and we're going to submit it. I also created here a requirements text. Everything is done from within the dashboards of GCP. You can also do it within automation, but this is not the way to go if you ask me. Like you can create a Lambda, but you will need service with your flexibility in it. And this is the trigger actually. So we can go ahead and copy it, go back to Superwise, create a new integration, add this new integration, and copy it here. Now the integration test will be trigger retraining. And you can go and create, we're going to test it, make sure that it has been created successfully, and we're going to run it. Now, what I want to make sure is that, and I'm sorry, great, let's edit this one, great. So I want to do the notification or the webhook will be triggered when a detection happened and also as a resolution. So the trigger will be, will run according to, will run for both scenarios. Okay, conditions, it's going to be after 3 days. Let's do 2 days because I think 3 days will work as well. Distribution shift will be +3. This is what Superwise realized. And scheduling will be every day at 4 p.m. Okay, we're going to work soon and introduce new features of hourly. Right now, it's only daily and weekly. Basically, it's running some heavy computation on all the models and so on, and eventually the notification, as I said, and then we're going to go ahead and create the policy. So amazing. We have a policy in place. Incidents, skip the tour, not yet open because no data was streamed. And integration, we just created one. So it's here. Let's go ahead and check our status of Vertex. See where we're standing with it. Okay, superb. So we have an endpoint. Let me show you. It's going to happen in here. So this is our endpoint, and the Vertex model, this is the URI that I printed. So this is what I need for the last step. And we can go into our endpoints and have a look. It's going to list all the endpoints. Right now, we're going to have only the diamond price predictor here. It's going to have 2 models. I think because we ran multiple steps, and only one of them getting 100% of the traffic split. In addition, you can see many different metrics about how many IOs and prediction per second and the performance and so on. Also a nice feature that I saw from here, you can log into the model and test it from here. So if you want to test and make sure that it's running, feel free. I already did the work for you and you have a script to do it. This is the last step. And right now, we're going to simulate real-world data stream. So our endpoint did not change because we had it before, so this is why it's here. But in case you're doing it with your on a new endpoint and so on, so please copy this one here. And then this is the URL where we're going to send our request or our predictions to. We're going to create an authentication to GCP just to make sure. Instances, this is how the payload expects the data to arrive. We're going to load the entire data set of the diamonds, and we're going to split it, or we're going to have 2 different data frames. One of them, basically, it's like a pointer, it's a reference, but leave it for now. The expensive DF would be all the expensive diamonds sorted descendingly by price. So the first one will be the most expensive one and goes down. And the data frame would be all the data frame like the model is expecting. And now we're going to do some counter of 30 days. And we're going to do, each time we're going to deploy a timestamp from the amount of days before. So 30 days before today, 29, and so on. And when we reach the last 10 days, because the model has 5,500, 5,400, more than 10,000 USD diamonds, then we will be able to send the data from the expensive one. So basically what's going to happen, let me run it. Basically what's going to happen is in the first 20 days, we're going to see the graph, the predictions pretty much stable. And then all of a sudden there's going to be a bump. It's going to reach the skies, I don't remember what's the most expensive one. I think around 20,000 USDs, and then slowly it's going to converge back to how it was before. So as you can see, uploading the data, 12, 11, 10, bam, 1800, 1600. This is the average of the data set. So it is sending us the data, and see how fast it is, by the way. So I jumped over the code, sorry. So we're gonna create the token, and we're then gonna do a post request to the URL of the endpoint. Each time we're gonna send 500, the chunk would be 500 prediction, and look how fast it was, okay? So I just sent 30 times 500, so 15,000 predictions, and it finished fairly quick, okay? And it's in a while loop. I think it can do batch way faster than that. And now let's see the Superwise. In the activity log, all the transaction logged as we expected. So I'm going to do, I'm going to look in the activity log page, and great, seems to me like 500, 500, 500, many different prediction were sent. We can also go to Google, look at the endpoint, and see the metrics in here. It's quite nice. Let me load the data graph. Okay, so there it is. There's a peak of 62 per second, 62 per second. And that's perfect. Now, until now, it's going to take for Superwise, as I said, it's a daily cron job, but I've exposed a small endpoint that will help us trigger that monitoring capability from outside. Just let me do it real quick from here. I'm on another window. Let me just make sure that it is ready. Great. So we have the endpoint ready, and I'm going to run the endpoint that I just created. It's not going to give me any output. Perfect. So I triggered the policy to run right now on the data, and it's going to take a few minutes, and let's go ahead and look at what Superwise make out of these predictions, right? So first of all, we're not going to look at baseline anymore. We're going to look on the production data of the last 30 days. And of course, you can look on different versions and so on. We're going to look at different segments. So if you have different marketplaces or different countries or different segments in your data, you can filter and define them in here. And all of a sudden, you can see that the caret distribution changed. In addition, the prediction distribution changed, and things are happening. Okay, so which is quite good. And we can also go to trends page. We can see the quantity of all the last month. We can skip the tour, so we can choose date range in here. Great. So from the 25th of March until the 19th of April today, let's add some metrics and let's do input drift. So as we said, pretty much stable, and all of a sudden a bump. And we can also define distribution shift for caret, for example, looks even more intense. And we can define many different trends, and it's super useful to look at it and have like KPI dashboards done and ready for you. Again, I'm not a data scientist, and I'm also not in the business part, so I don't really care about these graphs, but however, they do drive value. I'm talking about the automation, and what I care about the most is having the policy recognizing that something happened and triggering a new pipeline. So I'm going to look on incidents, and I'm going to look on the closed one, because the second we are understanding something happened, we will trigger a refresh. And from, as you can see, it didn't reach the point yet. So until it will, let me just make sure, you know what, I can open our logging system and see where it's at. I knew it's going to take a few seconds, so sorry about that. I'm also not, you know what, leave it. Let's give this a few more seconds, and we can go and explore, or maybe summarize and talk until it will happen. It's going to take a few more minutes. And if not, I've also prepared another workspace of Superwise with the incident open. But right now, let's talk about short summarization, because I feel like we're hour and 40 in, a lot of data to process. So let's talk in general. So we started off with writing a simple data science training serving pipeline. Okay, more on the training part of it. So we extracted the data, we validated it, we prepared it for the training, we ran a training step, evaluated the results, validated the model on a new unseen data set, and then we added the model into Superwise. After we added the model to Superwise, we wrote a small Flask application that is being Dockerized and deployed into an Artifactory of Google. And each time a new request gets to it, it sends the data to Superwise and returns also the predictions. We saw that it's also happening quite fast. Let's see if we reached it. If not, don't worry about it. It's going to take a few minutes. The reason is it's working for, it's like a job that's doing lots of calculation for many different models, not only this one. And until it will reach this point, it will take a few seconds. So I'm going to go back to one of my other workspaces where I prepared this diagram, where I prepared this workshop for. And I think it's maybe a lesson learned from this workflow to have everything in place in advance. And we're going to look the same exactly like before, same ID, same everything, diamond price predictor. And I'm going to look at incidents, and I'm going to look at the closed ones. And you can see that this is how it's supposed to look like. Let's increase it like that. And it will take a while and it will get there. We'll see it afterwards. But this is what Superwise understood on its own. It didn't need me to define which features to monitor. I just told him, understand it on your own. I didn't create any dashboard or fancy visualization. I just told him, hey, just monitor this model, make sure that the features are stable, and in case they are not, please create an incident, trigger some pipeline, and report me. You can create, I don't know, notification via Slack or an email, and let me know that something is happening. Okay. In addition, while it's doing so, a new pipeline will be triggered, and a new pipeline called retraining will occur. So this is how it's going to look like. The quantity here is 26,500. Each day it's 500, 500, 500. And this is how it's supposed to look like. In addition, you have the demo one, which is the fraud detection. You can also go and look at it. Okay, so this is on a longer scale and longer timeline, and it shows. The final step is to actually show the triggering. And this is where I want to save some time and have it running, to leave about 15 minutes for questions or consultations or whatever you guys want to do in the chat. And let me check what's happening in Vertex. I'm going to go, sorry, I'm going to go to this one. And let's go to cloud functions. Maybe that's also something worth mentioning, is that while all the big vendors tools are very fast to drive and get value and impact from, and they're very straightforward and understandable, it gets quite frustrating to debug problems, and you don't have this flexibility of just logging into some pod, opening a shell on it and just starting to play around and see what's going on. I mean, here you need to work with other components in order to understand what's your issue. So that's maybe also a lesson to learn. And let me see, I just did a post. So post on a blob, cloud blob, seems to me legit. Let me see, maybe. Okay, I know what happened. So great, we can do it live right now. So as you guys remember, this is where I this is the Google storage, the bucket that I used in here. But I'm gonna look in here. 1 second. Storage, and I think I deleted this bucket, and this is why the trigger will not work. I cleaned everything up before. So okay, I see someone ran with me. Thank you, Nicholas. Let's do something like that. We can just, maybe you can see what the idea. We're gonna download this one, and maybe not the best way to download it, but who cares? Let's open legendary Vim. What I meant. Thank you. Thank you. We're gonna print everything in here. And thank you, Steve. I see you here. Bugs. Someone told me when I was a long time ago, learn to love your bugs because that's what makes you a good engineer. So then we're going to look into 10,000 string. And if you can see, everything is super messed up in here. And I don't encourage you to actually edit those unless you really figured out how all this syntax looks like. But in this case, I'm just going to remove one line from this entire pipeline. I'm just going to remove the filtering of the 10,000 and make sure that the indent is good enough. And I'm going to save it. Thank you very much. And okay, so let's move one. And we're going to call it full pipeline JSON. And let's go and upload it. And we're going to do it in Itai bucket, and let's upload it here. Again, now you can use a GSUtil, you can use whatever you feel like. I'm using like the most simple one. Let's go to my tilde, and we called it full pipeline JSON, and let's upload it. And now it's going to take probably a minute until, so what we want to do is have this one, go back to our trigger pipeline, change the pipeline route. Okay, so we want to edit this one. Now it's going to allocate this machine all over again. So it will take, as I said, a few seconds, but we're just going to change this one, and we're going to change this one. And full data is not the name anymore. We change it to full pipeline. And there we go. And let's deploy this one. And great, it's going to upload it. It's going to do it again. Then in addition, we can go back to Superwise. Let's go to our production, the one that we did a workshop on and not the one I did in advance. So it's this one. And 1 second. And we're going to look at incidents. Want to see it in here, closed. Superb. So here it is. As I said, it's going to take a few minutes, but Superwise ran, it understood there is an issue, and then it triggered a pipeline. Okay. Now, my mistake, and I'm sorry for it, the pipeline was not wrong. Let me make sure that the Google function still uploading. And eventually, what we want to do, and we're going to mimic the behavior of Cloud Function. Just going to be gcloud functions, and we're going to call this name. Okay, this is all we're going to do. Let's just wait until it works. And now I'm going to go back to the presentation. I'm going to have 2 more slides, or even less. Okay, so yeah, 1 takeaways. First of all, thank you very much for taking the time. Check out our platform. Don't be a stranger. Feel free to approach me and talk to me about whatever you find and whatever you think and whatever cool packages you came up and find online. And until the Cloud Function will be deployed, let's have some takeaways. Okay, so first and foremost, work with pipelines. Don't use pickles or serialized techniques. Use something more robust than that. Okay, so it's going to be the scikit-learn pipeline that I just mentioned. The second one, continuous training should be data-driven. And I showed here a very simple retraining strategy, but the logic that we saw inside the Google Cloud Function can be enriched and complex, way more complex than it is. I encourage you to go to our GitHub repository, see our guides. One of the notebooks that we have over there is the retraining notebook, where we offer various ways of creating clusters of different times inside your data, and maybe creating segments on the fly, or doing some correlation understanding, or doing many different techniques in order to have your continuous training strategy as sharp as it needs to be in our world, okay? The next one is choose the right tool for your needs. And what I mean by that is, as you saw, we have an error if it's not usually in big company, in big platforms, it's not very intuitive, and you need to know everything, every aspect of it. It's not very flexible. So, and it also enforces you to work within frameworks that you sometimes don't want to do. You want to break it and have other ways of debugging and understanding and fixing and releasing and doing whatever you feel relevant for your need. Retraining, also something that you need to keep in mind. It's not always the solution. And it's also something that I come across a lot of times where, you know, the performance of my model degrades. So let's just retrain it. No, there are many different ways to do. Some of them written here, like fixing the upstream data. Sometimes you can, sometimes the data appearing wrong, or coming, the ETL changes, or the data engineers change a column name and use the capital letter instead of a small capital letter, a lowercase letter. And you can split into subpopulation instead and do multiple models instead of one for the entire segment or the entire population. You can recalibrate your model, which means you can add some delta or some addition to the outputs, like 10% more or 20% less than it's supposed to be. Thank you, dbeaver. And of course, adjusting your threshold for classification, because sometimes we classify email as a spam, and you know what? This is not spam. It's actually a newspaper that's from your favorite model observability platform. So many things can be fixed. One last thing that I promised. So this has been okay. This has been deployed, and we can run the Google Cloud Function, and then we get execution. Okay, I'm not running again from within Superwise, but I'm just doing the exact same thing. And we can go into Vertex. Perfect. And we can look in our pipelines. And we can see that, voila. Workshop Diamonds prediction, a new pipeline has been triggered 22 seconds ago with the entire data set with all the diamonds. So I think I'm more than good to answer questions if you feel. There's going to be a blog with about this workshop with many more information about setting up the project in GCP and doing some more stuff in the Flask application and some nice additions, more about Kubeflow as well. So feel free to look it up. We'll probably communicate it to you. Thank you very much for taking the time. Thank you for staying with us that late today. It will be great if you would be able to answer us. We're going to do this workshop with new additions in the future, and it will be nice to know if you guys are interested in having feature store or an open source pipeline technology, or using data tagging systems like DVC and experiment tracking and so on. You know, the ecosystem is growing and it's amazing. And that's it. Thank you very much, guys. I see that there are no more questions here in the chat. So have an amazing rest of the day. And we're Superwise. Thank you.